So, question 21, it's a triangle sort of question with missing angles, and we've got to find a missing length. BC, it's fairly late on, so you should realise there's no right angle triangle in there, so we're going to be looking at cosine rule or sine rule. Now BC is in a triangle at the moment that only has one length, so we need more information than that to get our length BC. Very easily we can see, of course, that this angle here will be 100, because it's on a straight line with the 80. But we still need a side. Now we can find the side BD by using the sine rule. And when we've got BD and we've got 105.8, we'll use the cosine rule to find BC. So let's start and find BD. I'll call that x. So using the sine rule, x over its partner angle, or its opposite angle, x over sine 45, will equal 7.4 over sine 80. So a little bit of rearranging, so x will equal 7.4 sine 45 divided by sine 80. So we'll work that out on a calculator. Our answer needs to be correct to 3 significant figures, so I'm going to carry 4 figures in the working out to make sure I don't get a rounding error. So we'll work out x to 4 significant figures to start with on our calculator, which comes to 5.313. So we now know that x is 5.313, so we'll use that in the triangle BDC. So I've inserted the cosine and sine rule formulas in just to remind you that at the front of the paper. So applying that to this situation, then we've got y squared equals 5.313 squared plus 5.8 squared minus 2 times 5.313 times 5.8 times cos of 100. Now you can put that all into a calculator in one go, and you can square root as well, which I'll show you next. So I've entered in the where I put the numbers into the calculator. Because the cosine rule gives us a squared, or where I've used y for a, I need to square root that to get the final answer. There's my, you can see I'm following exactly the formula. It can be entered into the calculator in the following way, and then that will give you an answer of 8.518, but we were asked to do it to 3 significant figures, so the correct answer for the length that we required was 8.52. And that's your answer.